Alright, so I'm going to be talking about partial derivatives and the chain rule. So we're going to be given a problem like this, where w is dependent on x, y, and z, x is dependent on uv, y is dependent on uv, and z is dependent on uv. So they're all chained together. And we know, we can assume that if we change u, then we're going to change w. So w is related to u and v. How do we find dw du and dw dv? So if they're related, then we could link them like a tree, right? W is related to x, y, and z, x is related to u and v, and so are the others. So we know that w and u are related. We know they're linked like a chain, and we know that x, y, and z are like conduits that link them together. This is what one chain looks like. And we could use the chain rule to get this here, dw dx, and this here, dx dw. The dx's will cancel out, and you get dw over du. So why would we use like the partial derivative sign, dw over dx, instead of the full derivative, dw dx? Well, that tells us that the partial symbol tells us that it's only one part of the full derivative. So partial w over partial x, it essentially allows us to ignore x and z in our calculations. And this symbol gives us important information, such as, yes, it's true that changing x changes w, but it also tells us that w is affected by other parts. So we can't just ignore the other ways, because that's just losing information. So what the partial symbol allows us to do is address them as their own individual chains. So that gives us the equation dw over du is equal to a chain of the partial derivative plus this other chain of the partial derivative plus the other chain of this partial derivative. Alright, so why is this the normal d instead of the partial d? Well, that tells us that everything has been addressed. The x chain has been addressed, y and z chains have been addressed. So now we're back to the full derivative. So in other words, the sum of parts is the whole. And a cool conclusion is that if this is a single variable function, if there's only one part, then the derivative is equal to the partial derivative.
Any thoughts on this?
Oh, no, it's just us. I have a question. If you woke up and I was there differentiating your parts, would you tell anyone? Alright. On an unrelated note, you want to go camping?